Hello, this is checkpoint 4.39. They want us to use Lagrange multipliers to find the minimum value of the function f of x, y, z. It's a function of three variables, is equal to x plus y plus z. And they want that subject to the constraint that x squared plus y squared plus z squared is equal to 1. And Lagrange multipliers tells us that if we assign g of x, y, z, it's three variables now, is equal to the constraint, then we can find the maximum and minimum by solving for this equation where we have the gradient of f is equal to lambda times the gradient, that's the gradient of g. Now, in this case we have three variables, x, y, and z, and so we're going to have three components for a gradient. So that would give us three equations, and along with the x, y, and z, there's also a lambda, so that's four unknowns. And that will give us our system of equations that we're going to solve for. First, let's figure out what f is, or the gradient of f, and that's just going to be 1, 1, 1. And the gradient of g is equal to 2x, 2y, 2z. Okay, and so we'll set up our equations. It looks like it's going to be 1 is equal to 2x, oops, this is a 1, is equal to 2x lambda. 1 is equal to 2y lambda, and 1 is equal to 2z lambda. All right, any which way. Oh, and also this is part of our system. Now, any which way to solve for this would be great. I see a lambda kind of all lined up here, and so I might be interested in solving for lambda, or maybe solving for x, y, z and putting it back into here in terms of lambda. Okay, maybe we'll do that. So we'll solve for x. X is going to be equal to 1 divided by 2 lambda, and it turns out that y is going to be the same and z is going to be the same. Okay, so they're all equal to 1 over 2 lambda, so let's put that into the third equation, or the fourth equation, where you have 1 over 2 lambda, that's x, and 1 over 2 lambda, that's y, and 1 over 2 lambda, that's z, and they're all squared and they're all equal to 1. So if we square them all, we'll get 3 of them, and we'll get 1 over 4 lambda squared is equal to 1. So let's solve for lambda. The reciprocal, so that gives 4/3, or 4 lambda squared is equal to 3, and we'll divide out by 4. So this will give us 3/4 lambda squared. So lambda will equal to the square root of 3 over 2, plus or minus, because we have to account for a plus or minus. Now, so there's a lot of combinations of points there. When lambda, well, we have to put in either the plus or the positive or negative. So we'll put that into here, and then we will get, let's do this in this color. X is equal to, if we put a positive root 3 over 2 in here, we're going to get, the 2's would cancel, that's just be 1 over root 3. Positive or negative depending. So it looks like we're going to get the positive part will give us the the maximum, and the negative part will give us the minimum. And the same thing is going to happen. They're all going to be the same. So y is going to be the same and z is going to be the same. Okay. All right. So if we put that all together, we'll put it back into the original function. F of, let's look at the positive parts first. Positive 1 over root 3, positive 1 over root 3 for y, and positive 1 over root 3 for z. And so it's just going to add them all up. So there's going to be 3 of them, 3 over root 3. And this is going to be your maximum. And then if we put the negative 1 over root 3, negative 1 over root 3, negative 1 over root 3, and add them all up, we'll get negative 3 over root 3, and this is going to be your minimum. Okay. All right, so I would encourage you to graph level surfaces. So these are functions of 3 variables, and if you set this function, the original function, equal to root 3 over root 3, set that equal to 3 over root 3, and you set that equal to negative 3 over root 3, you'll get, I suppose you'll get a plane. And then if you graph this x squared plus y squared plus z squared is equal to 1, which is a unit sphere, you'll see that these two planes will be tangent to the unit sphere, and they'll be tangent at these points specifically. Okay? All right, I hope that helps.